இதோட டிவைஸ் இருக்கா? Welcome you all for the fourth lecture session in air standard cycle. And today we are going to discuss the diesel cycle, which is also known as constant pressure cycle. The diesel cycle are also known as constant pressure cycle. The diesel cycle is an ideal cycle used in reciprocating diesel engines or compression ignition engines. So why it is informed as compression ignition engines? Because in diesel engines the ignition takes place due to compression of air. So this compressed air has high pressure and high temperature, which is sufficient enough to burn the fuel if it is injected inside the engine cylinder. Hence it is known as compression ignition engines. It is introduced by Rudolf Diesel in 1892, and in Otto cycle, in a petrol engines, the air and fuel mixture is taken inside and is compressed during the compression process. Hence there is a possibility of engine knock or auto ignition of charge, whereas in diesel engines only air is compressed during compression stroke. Therefore this auto ignition is eliminated in diesel engines. Hence the diesel engines are designed to operate at higher compression ratios. So there are 4 thermodynamic processes in diesel engines. I will show that in a PV and TS diagram. Before that, I will list out the thermodynamic processes. The process 1 to 2 is an isentropic compression process, and process 2 to 3 is a reversible constant pressure heat addition, and process 3 to 4 is an isentropic expansion process, and process 4 to 1 is a reversible constant volume heat rejection process. I will show all those 4 processes in a PV and TS diagram. Let us draw first PV diagram. So this is the PV diagram for a diesel engine. The 1 to 2 is an isentropic compression process. So the isentropic compression process is the process 1 to 2, PV power gamma is equal to constant, and after compression the heat is added at constant pressure. Process 2 to 3 is a constant pressure heat addition. So heat is supplied in process 2 to 3, and 3 to 4 is an expansion process, isentropic expansion, 3 to 4, and 4 to 1 is constant volume heat rejection, and this is PV power gamma is equal to constant volume heat rejection process. So this is the PV diagram for a diesel cycle, and this is the clearance volume of the engine cylinder, and this is the swept volume, and here the volume is V2, and here the volume is V3, and here the volume is V1 is equal to V4. V1 is equal to V4. So this is the PV diagram for a diesel cycle. Then I will draw the TS diagram for a diesel cycle. In the TS diagram, the same 1 to 2 is an isentropic compression process. So process 1 to 2 is an isentropic compression process. S is equal to constant. Then 2 to 3 is a constant pressure heat addition. Is a constant pressure heat addition. 3 to 4 is an isentropic expansion process. Then 4 to 1 is a constant volume heat rejection. So TS diagram is also drawn. Now in this PV diagram, there are certain ratios to be remembered. Let us start with the first one, just the compression ratio, which is denoted using a letter R, compression ratio, defined as volume after compression, volume before compression to volume after compression. So that is equal to V1 by V2. Then cutoff ratio, which is denoted using a symbol rho, and it is a ratio of volume when fuel supply stopped to the volume when fuel supply starts or started. The ratio, so we can say V3 by V2. So here the fuel supply stops and here the fuel supply starts. So V3 by V2 is the cutoff ratio. And expansion ratio, so this is actually in the process 3 to 4 represented using R suffix E, expansion ratio. So volume after expansion, it is a ratio of volume after expansion to the volume before expansion. So in the expansion process, volume after expansion is V4 and volume before expansion is V3. Now I can develop a relationship between this compression ratio, cutoff ratio and expansion ratio, which is R is equal to V1 by V2. But we can see here V1 is also equal to V4. So I can write this as V4 by V2, that is equal to V4 by V3 into V3 by V2. So from the definition, the V4 by V3 is actually expansion ratio, V4 by V3. Therefore R is equal to RE. The V3 by V2 is a cutoff ratio. So we can develop a relationship between these three ratios. Compression ratio is equal to expansion ratio into cutoff ratio. So with this information and input, we will start derive the efficiency of a diesel cycle. To start with efficiency of a diesel cycle, we have to develop a relationship or correlation for a heat supplied. So heat supplied is equal to, so heat supplied is actually at constant pressure process. So for a constant pressure process, the heat supplied is equal to m into, since it is a constant pressure process, Cp into, after the heat addition the state is 3, therefore T3, before heat addition the state is 2, therefore T2. So mCp into T3 minus T2, this is the heat supply, and we have to find out the heat rejected. Heat rejected is equal to, it is heat rejection takes place at 4 to 1, the process 4 to 1. In the process 4 to 1, it is at constant volume, the process 4 to 1, the heat rejection is taking place at constant volume. Therefore, mass into Cv into, after heat rejection the state is T1 and before heat rejection the state is T4. So, we have to write T4 minus T1. The thermal efficiency of a diesel cycle can be defined as a ratio of work done to the heat supplied. So, work done can also be written as heat supplied minus heat rejected, in denominator it will be heat supplied. So, we have to write the formula for heat supplied. The heat supplied is m into Cp into T3 minus T2, and heat rejected is m into Cv into T4 minus T1 divided by the heat supplied is mCp into T3 minus T2. So, by rearranging this expression, I can get 1 minus m into Cv into T4 minus T1 divided by m into Cp into T3 minus T2. So, in this expression the mass in numerator and denominator got cancelled and Cp by Cv is gamma. So, I can write 1 minus T4 minus T1 divided by gamma into T3 minus T2. So, we can write this equation as 1. We can inform this equation as equation 1. And now we are going to develop the relationship between the temperatures T4, T3, T2 in terms of T1. So, let us take the process 1 to 2. The process 1 to 2 is an isentropic process. We know for an isentropic process T2 by T1 is equal to V1 by V2 power gamma minus 1. What is V1 by V2? It is a compression ratio R. So, we can write the T2 as T1 into R power gamma minus 1. So, this is one expression. Expression 2. Then we can write the process 2 to 3. Expression for process 2 to 3. The process 2 to 3 is a constant pressure process. Therefore, process 2 to 3 is a constant pressure process. For a constant pressure process 2 to 3, we can write the expression T3 by T2 is equal to V3 by V2. V3 by V2 by definition it is a cutoff ratio. Therefore, T3 can be written as rho into T2, whereas the rho we can write as it is but T2 is T1 into R power gamma minus 1. So we can write T3 in terms of T1. So this is equation 3. Then we have to write the T4 in terms of T1. So the T4 by T3, this is for a process 3 to 4. The process 3 to 4 is actually isentropic process. We can write PVT relationship for isentropic process between temperature and volume. So T4 by T3 is equal to V3 by V4 power gamma minus 1, but we know V4 by V3 is Re, therefore we can write 1 by Re power gamma minus 1. But we know the Re is nothing but, from this relation we can write Re is equal to R by rho, right? So that we have to substitute here. When I substitute here, I can write rho by R power gamma minus 1. And T3 we know it is rho into R power gamma minus 1 T1, and here I can write rho power gamma minus 1 by R power gamma minus 1. So this R power gamma minus 1 and R power gamma minus 1 got cancelled. So I can write this as T4 is equal to rho power gamma into T1. This is equation number 4. Now by substituting second equation, third equation and fourth equation in equation 1, I will get the equation 1 as efficiency of diesel. In that equation I have to substitute all this. Efficiency of diesel engine is equal to 1 minus T4 is rho power gamma into T1, and T1 as it is we have to substitute, divided by, you have gamma and then you have to substitute T3. T3 is rho into R power gamma minus 1 and T1 minus T2 we have to substitute. T2 is T1 into R power gamma minus 1. So after this, if you rearrange, you will get 1 minus, you take T1 common term, R power gamma minus 1 common term, both. So in numerator only T1 common term, so T1 into rho power gamma minus 1. In denominator you take gamma, R power it is already available, R power gamma minus 1 and T1 you take common term. So the remaining is only rho here and here 1. Okay. So in this one the T1 got cancelled. So remaining can be written like this: the efficiency of diesel cycle is equal to 1 minus rho power gamma minus 1 divided by R power gamma minus 1 into gamma into rho minus 1. Okay, we can write like this. So this is the expression for diesel cycle. And in this one we can rearrange like this: efficiency of diesel cycle is equal to 1 minus 1 by R power gamma minus 1 into rho power gamma minus 1 divided by gamma into rho minus 1. We can also write like this. in this equation, rho is always greater than unit T. As rho is always greater than unit T, the rho power gamma minus 1 by gamma into rho minus 1 is also greater than unit T. Hence, for same compression ratio, since this is more than 1, for same compression ratio, we know efficiency of Otto cycle is equal to 1 minus 1 by R power gamma minus 1, right? R power gamma minus 1. This is the efficiency of Otto cycle. And here you have the efficiency of diesel cycle. Since this is more than 1, for same compression ratio, if you see these two, if you compare these two, this is more than 1 and compression ratio is same. Hence, for same compression ratio, efficiency of Otto cycle is greater than efficiency of diesel cycle, right? And then, but as compression ratio of diesel cycle is, or diesel engine we can say, or diesel cycle is more than Otto cycle, the efficiency of diesel cycle is higher than Otto cycle. Okay. So now this is the derivation for diesel cycle or constant pressure cycle. All these results we have to remember what is compression ratio, cutoff ratio, expansion ratio, and this relationship Re is equal to R by rho, and we have to derive the relations between the temperature T2 as a function of T1, T3 as a function of T1, T4 as a function of T1. Then substituting in the equation, we will get the efficiency of diesel cycle as mentioned here. Right. Thank you.